This is going to be trial 2. Today we're going over project 1 for fundamentals of aerodynamics. We were given a wind tunnel and we got to build it on Ansys Fluent. And for reference, I will be going over the 20 hertz. So here in Ansys, I already booted up the workbench. You want to go to the workbench, and now on the left side, you go to Toolbox, and you want to get this fluid flow, Fluent. You want to drag and drop it. Now you're going to be given this. So with this, you're going to want to start top to bottom. So you want to right-click on Geometry, and you go to New Design, Modeler, Geometry. And you want to click that, and you want to wait till it opens. I'm gonna have to change the screen in a second. All right, so now you should be able to see the new screen. So here we want to go up here. We were going to start up here in units. We were given everything in inches, so to not convert and to be more accurate, we're going to change it to inches. We're going to want to click on this XY plane so we could see it better, and we want to orientate it so the Z axis is sticking out at us. So we have the X and Y perpendicular to each other and we could see it better. All right, so we're going to want to go to sketch here and line. We're going to start sketching out our wind tunnel. So we go to draw line, we make a line, and after that, we want to go to our dimensions, and we want to give it a dimension. It doesn't matter how long anything is, since we're going to change it. So we first start off with our settling chamber. It's going to be 15 inches. Oh, I want to zoom out. All right, and we're just going to keep on rinsing and repeating that for every step of the way in this part. So we're going to go here, and the next section is going to be the contraction chamber, and it's going to be 24 inches. All right, so we go back here. After this, we reach the test section, which is going to be, oh, I was close, 12 inches. And after that, we go to the diffuser, which is going to be our longest section, and it's going to be 42 inches. Okay, so now that we have this, we're going to want to go and make our, we're going to go back to draw, we're going to go to line, and we're going to make vertical lines like this going down. And this is to make the height of each section. And once again, it doesn't matter how tall they are, just try to make them straight. It doesn't matter if they're on the dot, we could fix that later. All right. Okay, so now that we're here, we want to go to constraints, and we're going to go to midpoint. And what we want to do, we want to get the vertical lines, and we want to click the vertical line and then click the point that appears. So it drags it like that. If you didn't center it correctly, this is going to help later on. If you mess up here, the result is going to be all out of whack. That's not good. All right, so back to dimensions. We're going to give all these heights. So starting off with the settling chamber, we were given height of 22 inches. And now after the settling chamber, we start the contraction chamber. It's also going to be 22. Oh, did I mess it up? No. I just did that. All right, my bad. Okay, so right here, contraction chamber, it's also going to be 22 inches since the contraction chamber doesn't change, but the diffuser does. And since the diffuser, the end of the, or the, sorry, not the diffuser, the nozzle or contraction chamber, the end of the contraction chamber is going to be the same height as the test section. So we're going to want to change this height to 6 inches, which is what we were given. So it drops from 22 inches to 6 inches. And now this is going to be the end of our test section, beginning of the diffuser, which means it's going to stay at 6 inches. And the only tricky part that I had to find out was the height of the diffuser, and how you have to figure out the height is that since you were given the half angle of the diffuser, we were given half angle of diffuser of 3. So what we do is you take the of the tangent of the angle equals to the length that we're trying to find over 42 inches, which is the length, and we solve for L. We get approximately 2.2. So now to find the height, we get 6, which is the height of the test section, and we add it to 2 times that length that we found to find the total length of the test section, of the end of the diffuser, sorry. And that goes out to be 10.4023. I think it rounds it down. Yeah, that's fine. All right, so now that we have all of these down, we're going to want to go back to our trusty line, and we're going to want to connect the dots. And I've already messed up doing this, and it's a pain to fix later. So I'm going to go really slow. All right. Going to check that they all connect before I proceed. Okay, so next step, we want to go to modify and trim. What trim does is just removes the stuff that you're pointing over. So you just click it, and you also want to get the bottom ones, and this removes what you're clicking. And what we want to leave is the outsides, since those are the edges of our wind tunnel. All right. So now that we're here, we want to go to concept up here, and we want to go to surface from sketches. Now that we've done this, we go to this drag up top, select box select, and we highlight this, and right here, base objects, we want to apply that, and we go here to generate the skin, and this is what we're supposed to get. All right, so I'm going to change screens once again. We're going to go back to the workbench. So here in the workbench, we just finished up with that. We're going to want to go to the mesh now. So we're just moving our way down. We edit. And we open that up. Right click. Okay, so I'm going to share the screen now once more. Okay, so now we're faced with this. We're gonna, what I just did, you just click the Z-axis again. Now you're here with a more familiar face. And now we go to mesh, and we want to right click it and we want to go to insert, and we're going to look for method. And so we click method, and here we're going to click on the wind tunnel, or I think we have to click on geometry first, and then here, and then apply it. And once it changes colors, you did it. So woohoo. Now we go back here to the mesh. What I just did, I just changed this element size to 0.01 meters, so you get more stuff out of it. And yeah, we're gonna, and then after that, we're gonna generate our mesh for now. Okay, so this is good. This is what we want to see. So after this, we want to go up here to the edge. We're going to want to select the edge. So how this works, we're going to want to click it and press N on the keyboard. And what that does, it lets us name our components. So this component is going to be the inlet. And this component is going to be the outlet. And then after that, we click all of these, click all of these. Yeah, we click all of these like that. You have to control select it. And we want to name this the wall. Okay. So now that we have that sorted, we want to right click right here and we want to update. Okay, so our update was successful. Now we're done here. We're going to want to go back to our workbench. Change back to that screen. And we want to we want to go to setup, double clicked it, starting up Fluent. This is the final step, I believe. It's going to take a minute. It's taking a little bit of time, I guess. Or wait, no, it wasn't. I was just not, it just didn't pop up for some reason. All right, so this is what we're looking at right now. And so we want to go to double precision. We want to click on that and just change the solver processes to 4 and click start. It just stopped recording. We'll just fix that and go back to Fluent. All right, so we're put right here. And we're going to wait till this all loads up and we're going to click OK. Get rid of that pop-up. Should be over. Okay, nice. So we're here. This is what we want to see. And on the left side, we're going to go to our models, and we're going to go to this viscous SSTK omega, and we're going to want to edit that. So here we're going to want to click K epsilon, and we're going to click enhance the wall treatment and pressure gradient effects. And we're going to want to click off that checkbox and click OK. So now that that's set, we want to do our boundary conditions as well. Where is this? All right, here, boundary conditions, inlet. We want to edit our inlet velocity. It's gonna bring up a pop-up display right here. So the velocity of the inlet, you just want to, so we know that we were given the velocity at the center of the test section, which was, well, with the 20 hertz, the velocity in the test section was 4.61 meters per second approximately. So basically, you just relate that with the ratio of the diffuser areas, and at the end you get the inlet velocity, which is 1.25624 meters per second. So 1.25624 meters per second. Okay. So now that we clicked apply, click close, I'm just going to double check that because I'm a bit paranoid. All right. Perfect. Okay, so now we're going to go here to the reference values, and we're just going to want to put here compute from inlet. It's an important part. And now that we're done here, we go to initialization, and we're just going to initialize it. And you just got to do that before you run calculations, or else it it just throws a tantrum. So number of iterations, I just put 500 to have a good sum of results. And at the bottom, let's click calculate. And it's going to give you all the graphs. And once it's done, click OK. And so here, you want to go to graphics. And to get the contours, you want to click on the contours. Let's say you want the velocity, so velocity magnitude, and you want to do it. Sorry, you want to do it over the wall or body. Let me see. Yeah, no, you want to do it over the interior surface body. So you're doing it against the wall, basically, I guess. And this is what it's going to look like. It makes sense. Lighter colors, obviously, lower velocity. So once it reaches the contraction chamber, velocity increases. In the test section, it's constant. And then in the diffuser, it begins to decrease. And just to show, if you want like static pressure, compute that, it's going to be the opposite since one goes up, one goes down. So now we got that. And finally, to top this off, we're going to show how to export this for Excel. So at the top of the screen here in results, we're going to want to create, and we're going to do line and rake. And we're just going to, so what we're doing here is we're creating a center line to measure everything from. So we click on center line, and we change this over to rake, and the number of points. Sorry, not 2,200. Okay, so x0, x0 is going to be at the origin, since that's where we started it from. It's going to be really simple. And then our x1 is going to be the end of the like the length of the wind tunnel, sorry. So that's 93 inches to meters. Yeah, it's asking for it in meters. So that's a 2.362 meters. And y0 and y1 are going to stay the same since you're just acting on the center line, so it really doesn't matter. All right, so now we create this. Cool. So now that we got that, we go to all right, and this was the part that stumped me for a minute. So to export this to Excel, you want to click export, and you want to click solution data, and you want to measure everything from the center line. And here you're gonna press whatever you need. So for example, for our project, we needed the static pressure, we needed dynamic pressure, we needed total pressure, and we also needed the velocity magnitude. And what we also want to do, we want to change this over to ASC2, which Excel could read. And the delimiter we're going to change to space. Just makes it easier. And here we're going to write it. Just change it to whatever file you want to put it to, and you should be fine. So I'm just going to close out of this, close out of that. I think you could see the file part. Let me double check. Okay, yeah. Okay, so that's the end of the project. There you go.